Hello, hello. Okay, so this is part 2.1 and 2.2, part 2, talking about the history of the atom. We had just finished talking about some radioactivity, how Ernest Rutherford had discovered these three particles, alpha particle, beta particle, and gamma rays. Going to kind of continue off of here. Now, currently, if we go back to our model, Democritus and John Dalton came up with the hard spheres for the atom. So those were their two ideas. Then J.J. Thomson has a different model of the atom, and he comes up with something called the plum pudding model. And this is the model that's used for around the mid-1800s to the early 1900s. And then Ernest Rutherford comes in with some of this radioactive stuff. So again, hard spheres, plum pudding. Now we're going to look at Rutherford's model. So he looked at radioactivity. So the atom currently, which is around 1900, that's what circa means, around that estimated time. We have the plum pudding model by Thomson, which was a large positive sphere, and then your negative electrons spread randomly, kind of like raisins are in plum pudding. And those negative electrons are embedded into the positive sphere. Then Rutherford came along and did an experiment. So with his radioactivity, he came up here, put some radioactive substance in this block here. Again, there's a little slit, kind of got a slit here, so that those alpha particles can come through and do this experiment. So then he's got a thin piece of gold foil here. Now, if the particles were, if our model of the atom was this, where we have a big positive charge, then the majority of your atoms will come through, and then some of them will be deflected by that positive charge. So again, alpha particles are positive, hitting a big blob of positive stuff. You might have some angles that are scattered, but what he found, so he did find that, where's my mouse? He did find that a lot of the particles came through and a lot of them deflected. But he also found that some of those alpha particles actually deflected towards the observer again. And that was weird because what they were expecting was that they all go through. They didn't expect to shoot these beam of particles and then have it come right back at you. Don't quote me on this. I'm going to say it verbatim, but Rutherford is said to have, or is quoted with having said, it's like shooting a gun at a piece of tissue paper and the bullet comes right back at you. So that's about how insane these results were. So then when they started looking as to why they might be deflecting so incredibly much, they came up with the theory that instead of having this big blob of positive charge for your atom, you instead have a really dense core that we call the nucleus. So this is how we discovered the nucleus. Kind of looks like this. So if we've got this hard core called our nucleus, then we've got our electrons living out in big whole bunch of empty space. So ultimately, his nuclear model, or the nuclear atom by Rutherford, is that you've got a nucleus and a whole bunch of empty space. Now, with his interpretation of what was happening in the experiment, you've got incoming alpha particles, and then some particles are able to travel straight through because, again, it's a whole bunch of empty space. Some of them hit the core and, like, deflect sideways. And some of them will hit the core head on and bounce back because the core is so solid and so dense. So because of this, they changed Thomson's model and came up with the nuclear atom that it's kind of that core center, really big space around the nucleus. Anything else I'm forgetting? That's kind of it. I know I've said that a lot, but kind of important idea. Okay. Oh, here, perfect. Here we go. So Rutherford postulated a very small, dense nucleus with the electrons around it. Most of the volume is empty space. Atoms are very small, 1 to 5 angstroms. That's a unit for angstroms. 1 angstrom is equal to 1 times 10 to the negative 10th meters. So if you need it for comparison with like how small or how a meter is, they say that an atom is 1 angstrom wide. And so it's kind of a unit of measure in order to help with atoms. And then our nucleus is really, really, really small, so about 10 to the negative 4th angstroms. 4th angstrom, sorry, I had a little technical difficulty there, so let me get back on where I was. Okay, so really small, and this is the model of the atom around early 1900s. So let's get back to my timeline. So we've talked about Robert Millikan, some radioactivity. Again, Ernest Rutherford came in there with 1910, and that was the nuclear model. He later did some more experiments in 1919 and found the actual protons. And then the last person we need to talk about is James Chadwick. We're not going to go into in detail about him, but he did come up with the neutrons about 1932. So that's kind of the history of the atom. There have been some changes that we'll get into when we get into chapter 6, talking kind of about Schrödinger and kind of the current model of the atom, looking at wave theory and things like that. But this is the basic history that you need for this class. So hope that was helpful, and see you later. Bye!